Check, check. Oh, Casey, can you hear me? I didn't see you come in.
Yeah, I hear you.
Excellent. All right. It looks like we're up. Welcome, everybody. Here is a link to the agenda. Resting serious face. The first item, subtleties or questions we need to work out. Yoichi, you put something in about EIP 96. Is that still warranting any discussion?
So when I saw it, the pull request contained three different programs, three different hex codes, and one of them should be deployed. Well, so one is the init code. I don't have to think about this, but there are two different code in the pull request. I think I know which one is the right one, but the other one should be removed, I think.
Let's see. Okay, hold on. I'm gonna check myself. So, Yuichi, are you talking about the where it says block hash contract code is set to blah blah blah, and then down below it says something about the EVM bytecode and the EVM init code?
Exactly.
Okay, hold on. So let me just. I'm gonna compile the serpent and see what that gives you. Hold on.
And while Vitalik's looking that up, is there any other implementations that need to be checked? Is there a Solidity one?
No, this is the only implementation.
Pavel had some comment there about being a signed comparison.
Okay, yeah, so the code at the top is just like something old and incorrect, and I'm just going to ignore that, or I'm going to edit that rather. I'll do this right now.
Thank you.
Okay, great. I think that resolves that, right?
Yeah, sure. It's a minor editorial issue.
Mm-hmm.
Great. Okay, the next item is EIP 603. Matthew DiFerrate had a comment in the agenda that kind of explains his reasoning for implementing different curves. So, Vitalik, were you going to say something?
Yeah, I was just going to say that I'm increasing. I am a bit more in favor of this than I was last time, basically just because of seeing that we don't have, or just seeing how inefficient the other curve is. Though.
Yeah, let's have Matt, who's on the line, explain it to everybody, and then we can we can go through the pros and cons. But it does seem like a neat EIP. So Matt, if you want to go ahead.
Sure, thanks. Can you hear me?
Yep.
Okay, cool. Yes, the EIP itself is just kind of like a copy of the other one, but the comment goes into the detail. Generally for me, the biggest reasons are the fact that it's like widely supported, widely implemented curve, and people won't need to roll their own implementations of things going forward. I mean, like Albion is relatively new, and yeah, it's inefficient if you use the alt one, right? The real efficient one version of that curve requires like heap execution, which is disabled on the vast majority of things. Beyond that, it's the ability to check, manipulate curve points on native transactions, and the fact that like tons of other coins use native, like SecP256K1 is native, like allows you to do nice pegs between chains on that. And I mean, the biggest thing I see is that like, using that curve securely is less trivial than using SecP256K1, right? There's only one group on that curve, and you can't really mess it up as if you just use like the normal curve operations, whereas on the AltBN, well, on BN 256 anyway, the curve, there's two groups. They have slightly different properties. If you choose the wrong one, you break. The CDH is easy. If you don't realize that there's two groups, there's way more mistakes there. But like, generally the strongest support is the community support, and the fact that so much supports 256K1, and it's way faster. But so that's my rationale, and it seems silly to add a curve and not also add the curve that is the one supported natively.
Mm-hmm.
Cool. I'll go ahead.
I don't have any. Actually, don't have anything to say that I haven't said before.
Cool. Is this the same curve that's in Bitcoin?
Yes.
Okay. Yeah. I mean, this seems like a good idea. Does anyone have feedback or any opposition or questions? Not to say this is getting accepted immediately, just wanting feedback right now.
This is obviously not going into Byzantium, but let's see. There is okay. One just question I have is how easy, like, for if anyone's in here has experience with the SecP libraries. So like the stuff that we already use for the EC recover, how easy or difficult is it to call specifically the parts that do elliptic curve adding and multiplying?
So I've implemented this in Geth, on my own, and it's very easy. Yeah, it's like
okay.
5 lines of code per opcode, really.
Okay.
And you're thinking that'd be the same across different bindings for different languages?
Yeah, because there's two different ways to add this to Go. You can use the the C bindings, which again those are portable across languages. There's also the BTC EC, which is which is also like a clear Go implementation if people want to use that. For parity as well, I mean it has the same, it exposes the same bindings. This EC recover kind of requires like at that level of access to bindings anyway.
Okay. Any other feedback?
What
I'm thinking is, if there's no opposition, this will be something that'll come up in a future core dev meeting, potentially the next few, and we'll make sure that EIP is up to standards, have one of the editors review it, and then reapproach this for official approval sometime in the future after everyone's been given a few weeks to comment on the actual EIP PR, since this wouldn't be going in until Constantinople anyway.
Mm-hmm.
Cool, sounds good to me.
I think I might have heard someone speak up. Was there anyone else?
No.
Okay. Great. The next thing we have... Oh, I think Yoichi dropped off for a second. Google's been having some problems this morning. I think they updated YouTube and dropped everybody who was logged on to it at like 8:58. At least all my screens refreshed. So maybe that's what's happening. Updates to testing. So this would be Martin, Jared, Casey, and Yoichi if he comes back. Martin, what is the summary for testing, unless someone else wants to take that?
So
Oh, and we have Yoichi back as well.
yeah, I was also kicked out a bit there.
Double-click me
you
out.
want to take updates to testing?
Yeah, Yoichi, we were just going over testing, and we were saying if anyone wants to give kind of an overall update. I'm not sure who's been most active in it, because I don't think Dimitri's here right now to give a solid or to give like a full summary.
Oh, okay. So now on Hive, we see better numbers. For OSLM, we have less than 10 errors. That's nice. For CPP-SLM, we are seeing somehow 700 errors, but I cannot reproduce them locally, so it might be just some pull request merged in CPP, but not merged in tests or vice versa or something like that. That could be the reason. I haven't been able to reproduce this. And then I started to receive many, so many people pointed out mistakes in tests in this week. So that's a good sign, I think. It's getting the CPP team against everybody else. So we are getting busier, certainly.
Okay, great. So the next thing would be, and basically agenda items B, C, and, well, what's coming up as C Part 2 are about gas prices and client implementations. So I think, unless someone has a better idea, we'll just go with the client updates first for implementation of EIPs, and then go through the gas price gas pricing for the opcodes. So we'll start with Geth. It looks like they're done with all their EIPs. Peter, do you have an update?
Yeah, so we are at the same place as 2 weeks ago. So essentially, we're mostly done. As far as I know, all new tests that have been added are still passing. The only 8 failing tests that we currently have, I need to investigate it, but there are some known issues with some tests. So I'm not sure whether these 8 failures are because the tests are wrong or something else is wrong. But apparently, we're mostly done. So we're just trying to... Oh, a cat.
Sure. Parity, I think that would be Arcady.
Yeah, I'm also working on fixing test issues. I think there is only a couple of tests, state tests that are currently not passing. And I also need to implement blockchain tests. I think we'll be ready in 2 or 3 days.
Okay. I think I saw Yoichi or Martin mention something about the parity test. Or Martin, you were just speaking up. Go ahead.
Yeah, so I'm wondering if it's possible, is it disabled now so that it's not possible to configure parity to run on Byzantine rules? Because it's failing all the Byzantium tests in Hive.
Yeah, you will need to use a branch that we have for that.
Okay.
I'll send you a branch name. Whatever.
Perfect, thanks.
Okay, great. Next we have CPP Ethereum. Who's in here? I know that Christian couldn't make it. It looks like... Or Yoichi, actually. Yeah, Yoichi. I think he might be up to date on that.
No, Andre.
Oh, Andre. Sorry. Andre, go right ahead.
Well, it's actually Yoichi mostly taking care of Byzantium updates now in CPP. So I know that there were several minor fixes during these 2 weeks. So yeah, no much details.
Yeah, I'm looking at the meta implementation progress PR in the CPP Ethereum repo, and it looks like 86 has a few, 100 has a few, and 211 has a few from the Google Doc that's kept up with. But yeah, that doesn't seem too bad. Looks like Jared and Yoichi covered a lot of them. Cool. Let's see, Ethereum J. And welcome, Mikhail. This is his first meeting. He's from the Ethereum J team.
Yeah, thank you, guys. We have implemented all the EIPs, and we are passing blockchain, state, and transition tests. successfully, and now I'm working to bring up to date VM tests and transaction tests. So we should be ready in 2 days, I guess. We just need to check that we are passing them too. So I'm bringing them to new format in our code, so we can support new format of those tests, so we can run and check how it works. So that's it.
So I forgot, is Ethereum J compatible with Hive, or is currently being tested?
Ethereum J has been compatible with Hive some time ago. When we are done with the test checks, I'm going to work on Hive to make it fully compatible.
Okay.
To make Ethereum J fully compatible with Hive.
Great. Definitely talk to the Hive guys about that. Reach out if you need me to get you in a Gitter channel or anything like that.
Okay.
All right, thanks for the update. Ethereum JS, I think that would be Casey.
Yep. As of this morning, we merged the elliptic pairing precompiles, and almost all the state tests are passing now. Thanks to the great efforts of recently joined contributors. Still have a couple of, well, about a dozen failures to debug. And blockchain tests even are progress on those. So expect to be passing the blockchain tests pretty soon too.
Okay, great, thank you. Let's see, Yellow Paper, any relevant updates on that, Yoichi?
Yes, this morning I noticed Afri pointed out one EP is missing, and that he was correct. The difficulty bomb delay and the block reward change. This was I had forgotten about it, so I added a PR about that today. That's the update.
Okay, awesome, thank you. Pyth app, Vitalik?
Not really any progress since last time.
Okay, and I don't see any other clients on the call. I need to reach out to the Haskell team. I think they're the only ones that are missing that are actively kept up with, because I believe Ruby is deprecated.
Mm-hmm.
Okay, so the next one is determining the gas prices and opcodes. That was tasked last time with Arkady and Martin. And I saw that Martin keeps up with a repository called Benchmark and the Ethereum. I'm going to post the link to it. But Martin, you can go ahead with your overall update, any issues, or just the summary.
Yeah, so in summary, we had a chat about this earlier in the week, me and Casey and Vitalik. And so based on the benchmarks, there's an analysis with some suggestions, and we've made some concrete suggestions based on that. Basically, let me just find the analysis here. So the current suggestion that we would suggest is that for addition, we would keep the current cost, which is at 500. Reasoning being that even if we increase it to 1,000, it doesn't really matter, because there's a 700 call cost, which we can count in on that. So the total cost would still be 1,200. So we can leave it. ModX, the analysis suggested we should multiply it by around 1.5 or maybe 2, but then it turned out that both Parity and CPP use a quite unoptimized version of ModX. So I think Vitalik, Vitalik suggested multiplying it by 5 instead. Is that right, Vitalik?
For ModX, yes. And my reasoning is that by multiplying it by 5, other people feel free to check this, but I believe that the exponentiation of 4096-bit numbers by 3 would still only cost something like 5,000 gas, which is still like not very high.
And continuing on scalar multiplication, the analysis wound up somewhere in the range of 30 to 50K. And yeah, I think we said 40K for it to be usable, and in the hope that it would that it could be further optimized in clients. And for pairing, Casey or Vitalik, do you guys have any notes about what we said about pairing?
I remember that I think we had decided that the current schedule that was in Ethereum, so the 100,000 base and 80,000 per point is fine, and we should just not change it.
Yeah, because that would leave us about a factor of 2 away from easy for easy recover, but still within acceptable megagas per second ranges for the hardware that we've been doing testing on, basically.
Okay, so looking at this, what is left to be benchmarked, or are we comfortable starting to make some decisions about the gas price for Byzantinium?
So I would hope that we can today just decide, yes, we'll use that scheme.
That's my hope too.
If during the coming weeks we find, or someone finds, that there's a denial service vulnerability with specific input vectors, then we might have to go back on that in some kind of emergency rollback or change. But yeah, hopefully not. That's hopefully not going to happen. So I don't think we need to do any more benchmarking before we make a decision. We'll make a decision and hope we don't have to go back on it.
Okay, that sounds good. What's the best? Oh, sorry if there's noises. That is my cat playing with a mouse that squeaks. So what is the best way to organize making these decisions? Should we use the benchmarking repo? Is there enough, just small enough to just talk about it over Gitter?
I think we can just, I mean, everyone who has had an interest in these things has been invited to see the results, read the analysis. I talked about it on Allcore Dev. So I'd prefer just to ask, does anyone in this call object to the proposed figures? And unless someone speaks up, I think we should just put in the numbers in the EAPs and then notifying the Allcore devs that these EAPs have now been updated, case implemented, and then we just roll it out in the tests and see if it works or not. If the client passes or not.
Okay, that sounds good to me. Anybody have any comments or objections?
No, I kind of agree. At this point, we should just pick whatever number we are currently at and think they are reasonable, and then just roll with it, because it's way too late already.
Sounds great. Okay, the next item on the agenda, review the time estimate for testing and release. As far as that goes, some of the thinking behind that was that if we felt that testing was close enough to being finished or finished, we could set a testnet block number, maybe even today, and just shoot for that so that we can stay on target for something. After which, as we get closer to the testnet or at the start of the testnet, we can set a block number for mainnet depending on how well the testnet goes. We would put that in there with the caveat that if testing, or if while on testnet we find a vulnerability or something we need to fix, we can delay. What does everyone think of that?
Seems fine to me.
So today is September 8th. In a week will be the 15th. 2 weeks will be the 22nd. I think block times are going to hit above 30 seconds mid-month.
No, they're gonna. I think they're gonna hit 30 seconds at the end of the month, rather. But I can check again.
Okay.
Yeah. It's gonna be. I'm pretty sure it's gonna be at the end of the month. But I will oblige with another. 425196. Let me just get the timestamp, and they can run the piece of code that I've run way too many times one more time.
Great. And while we're getting that, how long?
Okay, so the code says that we are going to hit go up to 30 seconds on the 22nd. And we are going to go up to 39 seconds around October 27th.
Okay. So as far as testing goes, oh, awesome. Welcome, Dimitri. And actually, Dimitri, are you able to hear me?
Yeah.
Awesome. We were just talking about if if the testers from the testing team and the client teams felt like they were comfortable declaring a testnet block number today, that we could do that, and then we could declare a mainnet block number sometime after the testnet starts or right before it starts. And then if testnet goes well, we'll keep the mainnet block number, otherwise we can delay it if we find some issues. In your opinion, Dimitri, where are we in terms of testing, and are we comfortable enough to launch the testnet in the next week or two?
Yeah, I think we're comfortable to launch the testnet, but still we don't have any news from Parity client or other client. It's just that only Get is working on a Hive consensus issue that we are having right now.
I think I talked recently. I talked to Arcady, and Arcady, is it still the case that you believe in the next week or less, at this point, I guess, 7 to 10 days, that Parity will be passing most of the Hive test?
Yeah, we should be passing all tests in 7 days.
Okay, that sounds good. So if that's the case, then I think that doing something like having the testnet 10 days from now, so something like the 18th, might be a good idea. What's everyone's opinion on doing something like that?
Sounds good. Sooner the better.
Yeah, I agree. And I mean, the reason for that is it's a Monday. I feel like Mondays are better to launch things because you don't have to work the weekend if you launch it on a Thursday or a Friday and things go wrong or anything happens. So it looks like, let's see, if we do that on the 18th and then we run the testnet for 2 weeks, we could launch on October 2nd. How long should the testnet be run for? Because I've heard figures between 2 and 4 weeks. I know there's some period of time where, you know, it doesn't really make a difference how long you run it after a while. We just kind of know it's going to be good or bad. What's the opinion based on previous experience with this?
So this is how long we run the testnet before the switch over to the main network?
Correct. That's the question.
Okay. So my answer is probably still going to be around 3 to 4 weeks.
Okay. Peter, did you have an opinion? I saw you talk for just a second.
No, I just want to say that basically, if things go wrong, I can imagine that they will go wrong pretty fast. So, yeah, I guess I would have said 2 to 3 weeks, but it doesn't really matter. But yeah, I don't think it really makes sense to run it for much longer, because if things break, it will break.
Okay. Well, the good news is we don't have to decide on a mainnet number today, but it sounds like the mainnet number may be on the 2nd or the 9th of October. So something like that would make everyone feel comfortable, it sounds like. Also, doing it on the 18th would give us 10 days to finish up testing, so that's going to give us a little more time than we need, probably, from what it sounds like. We can prepare.
Personally, I'd prefer the 9th over the 2nd, but, you know.
Okay. Yeah, well, I don't see why we should, you know, playing it safe sounds better.
Yeah, and so, like, so the block number will probably end up being, like, either 4.35 million or 4 point, somewhere between that and 4.4 million if it ends up dragging on later.
And that's for mainnet, right?
Yeah, for mainnet.
Okay. 8th, and then
just one slight note. Let's please not decide the final block number before the testnet forks, because I think for the Homestead release, we picked a number which was only a preliminary number, and then we kind of delayed it, and that resulted in so actually in Parity they had a release with the old number, and then they did a new release with the new number, and some of the clients forked over because they haven't updated, and they thought that they already have the correct block number. So if possible, let's try to see the testnet fork first, and then finalize the mainnet number.
Mm-hmm.
Okay. So as far as the testnet number, what's a good number for that would fall roughly around the 18th? Or yeah, the 18th.
One note about the testnet block number is, because the difficulty is very low, especially relative to the mainnet, if more hashing power comes online and starts mining on the testnet, then it can accelerate the date or time when the block number is reached. So should probably allow for 1 to 2 days, target 1 to 2 days later than the intended date. That way, if the hash rate goes up by 100x, then at least it doesn't, you don't reach the block number earlier than intended.
Mm-hmm. Okay. So what would you recommend? I guess that would be not doing that would be doing a block number that is a bit ahead of the 18th, I guess, or am I thinking of this backwards?
Yeah, that's right. I haven't done the numbers myself, but I can work on it real quick here.
Yeah, no problem. We still have some other agenda items, so we can kind of come back to this at the end. Whoever wants to try to come up with a nice, clean number for around that time.
I would like to suggest, I mean, since the testnet can be easily influenced, wouldn't it be better to, if we say today that fork the testnet on the 18th and set the block number, we don't decide the actual block number today, but decide it later so there's less variance.
Yeah, I'm okay with that. What would be the minimum amount of time before a testnet is released that a client would need to be released with these numbers?
Honest, we're already pushing that limit.
Yeah, I guess what I'm saying is, like, if we decide the number 3 days before, then everyone will have to update their clients, which is okay. But I don't know if that would cause problems if a lot of people stay on the old client and keep running Ropsten.
Some clients will definitely be on the old Ropsten. There's already a lot of clients on various forks of Ropsten. Anyway, the important thing is the hash power that's pointed at. that the hash power is updated, so that the miners update more than all clients.
Okay. So something like deciding the block number on the 13th or the 15th, would that be a combination of enough lead time, but avoiding a lot of variance in the block number beforehand?
Yeah.
Okay. Next Wednesday sounds good because it's midweek, so if there's any complications, we can deal with it. Let's say the 13th. Anybody opposed or want to push it to the 15th? I don't know enough about, you know, how fast these things can change to really make a determination. I'm just kind of throwing out numbers.
I think
I do know they change quickly. By the way, does price affect this? As far as
the
like
price, yeah. So, the price going down increases the likelihood that mining power goes down, which makes block times be longer. But well, it has the long term, so it makes block times longer. Though it does have the one kind of happy side to it, which is that it slightly delays the next two halvings.
Yeah, won't mention it on this channel. Just everyone check Gitter real quick.
Mm-hmm.
But basically, there's a rumor that would potentially decrease the price, so that's kind of why I'm thinking.
Not just a rumor. It looks like it's from everything I see inside the Chinese channel, it's very likely true.
Yeah. So basically, due to that information that I won't say because it's just rumor at this point, that would kind of make things weird. Anyways, man, that is interesting. Basically, let's decide it next Wednesday then, I guess, unless, does anyone have any opposition for deciding the testnet block next Wednesday?
Seems fine to me.
Just for an estimate, the testnet, Robson's currently at 1.63 million. So if we do 10 days, then we'd be about 1.69 million, unless I'm mistaken. And so one extra day would be 1.7 million, which is a nice round number.
Mm-hmm. Okay. That sounds good. 1.7 million would be a nice round number. Okay, I have that noted. Oh, my cat's freaking out. As far as the mainnet test block, so just basically what I'm wondering is, yeah, if the price drops dramatically, what does that affect the block time is the thing I'm wondering, because that's what a lot of people in the community would be wondering.
How does what affect the block time?
The price dropping, how that affects the, I guess.
Oh yeah, so in like basically because it makes the effect of the difficulty bumps like much stronger, but that's only if hash power really drops. In our previous experience, even large hash power like price drops have not in the short term led to mining power drops.
Okay, great. So it sounds like the risk isn't that high for the economic factors here.
Yeah.
Great. Cool. All right, so we have that block number done. What's the next item on the agenda? Oh, any other comments on the block numbers and stuff? In summary, something around 1.7 million is an estimate for the block number on Ropsten. We're going to decide it next Wednesday to see how the variant, or to see how difficulty and other things change in Ropsten between now and then. And we're tentatively trying to hit September 18th for the testnet block number, at which point we would start deciding on a mainnet block number that would hopefully be 3 weeks after Ropsten, which would put us at October 9th. That is an unofficial number for all the coin media that keeps saying September. It's not September, so it would be October 9th potentially, unless there's something goes wrong with the testnet. So item number 2 on the agenda is the snappy compression for dev P2P. That's EIP
Hold on,
706. Oh, go ahead.
Yeah, just a quick. So on when we decided to test this number, could we please just make it a quick? Someone pastes a suggestion to the all core dev channel in Gitter, and those opposed can raise their hands, and we can make it just.
I think that's a good idea. We're not going to have a call next Wednesday. I should have made that more clear. It would just be a Gitter chat.
Great.
Yeah, it would just be a Gitter chat. Because we already have somewhat of a number, and if things change, we can just adjust that number. For the block number, I should say. Cool. Any other comments?
Probably just a Gitter chat at the same time as the regular scheduled calls here.
Yep. You're talking about next Wednesday, right?
Yeah.
Yep. So same time as the regularly scheduled call, so 1400 UTC. We would have a discussion on the Gitter channel about the block number. I'll put that in my notes as well. So 1400 Wednesday. Okay. So the next item is EIP 706. This is a snappy compression for dev P2P. Peter came up with this. It reduces sync bandwidth by 60 to 80% and would affect the network layer of the protocol. I've reached out to Swarm developers. I think Daniel, who works on Swarm, has already commented a little bit on it. And we've received more comments since then in the EIP. Let me post it here. So Peter, if you can just give a quick summary and then we can discuss.
Yep, sure. So the crux of the EIP is that previously, I think when Ethereum launched, we had some plans to extend the dev peer-to-peer. Basically, that's the base networking layer of Ethereum, so that it employs compression, because currently it just encrypts whatever upper layer network protocols throw at it and just transmits it that way. And we had this idea, but nobody ever pursued it because it was kind of bashed together with some other changes. And the last few days, I was running some benchmarks to see basically how compression would impact performance, and it's quite staggering. So using Go Ethereum to do a fast sync on mainnet, it reduces download traffic from 34 gigabytes to 13. So basically that's about a 60% save. And on Rinkeby it reduces from 2.6 gigabytes to about less than 500 megabytes. So on Rinkeby it's more spectacular because it's quite full of spam. But the idea is that compression really can do an enormous save on the ETH protocol. So I tried to figure out how much code or how much effort it would take to actually implement snappy compression, or I mean compression in general for the dev peer-to-peer, and it turned out that it's really, really simple. So it's all it takes is that before a message actually gets to be encrypted and put on the wire, we can do a compression round on it, and similarly when it's decrypted from the wire, we can do a decompression round. And basically, I managed to, the whole code for this in Go Ethereum, in the Go code is about 38 lines. So I think it's a worthwhile addition, and I kind of wrote up this EIP to discuss it. Technical-wise, the EIP consists of bumping the version number of dev peer-to-peer from 4 to 5, and basically whenever the handshake arrives, if the handshake contains version number 5, then clients should do snappy encoding from that point onward. There have been some discussions with corner cases in the EIP. You can find it listed there. So one of the first questions is whether people feel confident about rolling out such a change or not. I've heard one concern about this change from the Ethereum team, actually from Piper Merriam. He was saying that Python itself doesn't have a pure Python implementation of Snappy, so this would entail Python having to actually wrap the C++ library, which they are a bit reluctant to do. As far as I know, all other clients, all other languages, Go, Rust, JavaScript, do have pure implementations for Snappy. So the only concern was that one open question is whether we want to have compression mandatory, or whether we want to do it as maybe a compatibility flag, and then clients can signal whether they want to compress or not. So these are basically my two questions. One is whether there's general interest to include something like this, and two, whether we want to, if there is interest, whether we want to make it mandatory or optional.
Mm-hmm. Is there some like a widely available specification of how Snappy works?
So I linked a Wikipedia article. I am personally not familiar with how Snappy works internally. I'm not sure whether Nick has some information. I think he may have looked into it.
Sorry, I missed the question.
So the question is whether you have any knowledge about how complex Snappy is internally. I'm guessing how complex it is to...
I looked at it briefly before, although not in great detail, and it's relatively straightforward if I recall correctly. And of course, as with most compression algorithms, if you really wanted, you could implement a dummy one that basically just doesn't compress anything.
I see. So in essence, it's important to note that the DevP, so the EIP proposal is backward compatible in that a client may choose to run version 4 and not do any encryption. So it is perfectly fine for some clients to upgrade now and some clients to upgrade in 2 weeks or in 4 weeks or whenever they feel like upgrading. So clients can do this completely independent of one another.
Mm-hmm.
I think it's a good idea pending more discussion. So this would not require a hard fork because it's part of the networking layer, so the clients would just have to implement this, correct?
Yes. If no, I mean, how much more discussion do we need, I guess, is the question.
I think, or did we just answered Piper's question, didn't we? I guess I was unsure if Piper's question was effectively responded to. Also, and I guess the other thing is like Andre and a few other people had a few sub-questions like to enforce a 16 megabyte limit on compressed size and a few different things. Oh, never mind. I see. Okay, Carol. Okay, Peter, you commented a couple hours ago about updating the spec for replacing lazy with 16 meg. Okay.
Yeah. So currently the spec states that the decompressed size is limited to 16 megs, and this essentially has the same limits enforced as the current DevP2P protocol. So this is nice because we don't need any extra effort around lazy decompression, and we can use the same rules as we currently have. So if the plain text messages or the decompressed message is larger than 16 megs, then it's just thrown out.
Okay. Arkady, do you want to elaborate on a comment you just made about having this be a sub-protocol level?
Yes, I've just added a comment suggesting that it should be negotiated for each subprotocol, because some subprotocols might want to disable that.
And why would they want to disable that? Is that for different subprotocols that would be implemented within the client?
Well, yeah, because some of them are already, well, at least we have the one parity that already uses compression on a different level, and we don't want to compress everything twice.
Well, so one of the problems with this is that it all of a sudden this means that I explicitly mentioned this scenario in the EIP, in the discussion, in the spec, that the problem with doing this on a subprotocol level is that all of a sudden, if I roll every single subprotocol all of a sudden needs to be aware of and needs to care about compression, and so that's already getting murky. And regarding the speed, as Nick was pointing out, that that Snappy essentially is kind of almost as fast as memcopy if it doesn't actually compress. So the Go implementation of Snappy, if you actually make it compress the JPEG images, which are probably not really compressible, it can compress, so to say, with about 15 gigabytes per second on a single core. So with those numbers, I'm wondering whether it matters if it does a round or not.
So I'm not suggesting completely taking it to the subprotocol implementation. So it will be still handled by the dev P2P, but the protocol will just declare one bit if they want compression or not, and that's it.
Well, yeah, but then the entire protocol needs a heavy update because all the capabilities, all the handshake message needs to be. So currently, the handshake message can be extended with extra fields, but I'm not sure whether the capabilities field itself can be further expanded. I don't think the protocol supports that, which means that to do such a thing, it would require a major update to the dev peer-to-peer.
Well, you're updating a version anyway.
Well, sure, but if it requires a ton of updates from everybody, then it's much less likely to be implemented by anybody.
Well, supporting compression also requires an update from anybody, right?
Yeah, but adding 20 lines of code to your code is much simpler than adding 200.
I don't think this is much.
I mean, the question is it worth the complexity? Because Snappy is ridiculously fast, and it's going to be a big gain in most cases. Is it worth complicating things to make it switchable? HTTP regularly, gzip compresses stuff that's incompressible, and it just works because it's the simplest way to implement it.
Well, HTTP has headers that allows to turn it on and off, right?
It does, but I'm saying that in practice, a lot of servers simply serve everything compressed, and gzip is a whole lot more expensive than Snappy.
Well, sure. My point is about giving choice.
But do we need the choice? Like, is it actually important?
Well, I said it why it is kind of important. We don't want to.
But given that Snappy is almost as fast as just mem copying it, and your processor and memory bandwidth are orders of magnitude faster than your network, I don't think the impact is actually meaningful.
Yeah, I think Arcady, the thing is, like, if there's nothing currently remotely faster than that, then implementing it as a sub protocol would only complicate things rather than having everyone go with the same thing that for the most part shouldn't be superseded for a long time. If there's something already implemented that's faster than Snappy that everyone can come on board with, that sounds like it would be better. Is there something that's implemented at a sub-protocol level that could be implemented everywhere that would be faster than Snappy?
That's not my point. I'm not suggesting an alternative to Snappy. We're already using Snappy. It's just that I don't want to compress the data twice with Snappy.
But, I mean, I understand that that's a bit of a code smell, but given that it's not actually going to have a meaningful impact on performance, does it matter?
Well, if it's a little bit of extra effort, I don't think it will be more than another 20 lines of code.
Okay, so it sounds like what you're saying is it's doable, Arcady. It does add a little bit more complexity to your client, though.
Yeah, but it's a minor complexity. It's not that complicated.
Well, it's complexity to everyone's client, not just Parity's client.
Or, no, what I should say is complexity. Would they be having to change their sub-protocols to not compress things twice? That's how I understood it.
Well, it's not.
I don't think it's on the table to change the Parity protocol.
Yeah, it's not only about the network. We use the same format for storing the files and all that. Well, yeah, anyway, we can discuss it in the GitHub issue.
Okay. Yeah, I'm okay discussing it further in the GitHub issue and getting a few more opinions. And then the next core dev meeting, let's bring it up again. I think by then there will also be some more people who utilize dev P2P who might have some other opinions on it. So that's not a problem. Also, we can get kind of better descriptions because I think there's just a little bit of confusion with what the arguments are about. So we'll talk about it more on the EIP. That's a good idea, Arcady.
Okay.
Thanks. So let's see. Is there any other topics or agenda items? Okay, great.
I can't think of anything.
Yeah, I'm good too. It looks like the estimate is around the 18th. We will be doing a testnet fork. Potentially that is block number 1.7 million, but that is obviously can change. At 1400 UTC this Wednesday, we're going to have a Gitter chat room discussion on what block number the testnet will be. And then after the testnet, happens, then we will decide on a mainnet block number that will hopefully be, like, this is super early, but we'll decide on a blocknet number between the 9th and the 16th, I guess. Just something in early October, basically. The 9th has been thrown around as a date, but that's nowhere near official. So the mainnet block number will be after we start the testnet, it sounds like, although we might have some recommendations beforehand. Thanks everyone for coming. Unless there's anything else, everybody have a great day.
You too.
Cheers. Bye.
Cheers. Thanks everybody.
Bye.
Bye bye.